Okay, so here's our system for the exponential function through these 2 points. And we saw that on the MCR video if you were here when we reviewed that. So anyhow, this is the system. Okay, how are we going to solve it? Well, I'm going to just use substitution. There's another way to solve it. It could have been used for the power function system as well. If you divide the second equation by the first or the first by the second, the A divides out, doesn't it? So that's another way of eliminating A in this case. Okay? But I'm just going to talk about substitution because we have limited time, and I've already done that. I've already shown you that. Okay? There's an assignment that involved doing that. And so if you did the assignment, hopefully you understand what we did. Anyhow, substitution. It's going to look very much like this until we get to the end, and we're going to find out that even though this is an exponential function, we're not going to have to use logarithms to find the base. Okay? We just have to do powers. Okay, so we solve the first equation for A. So we have 12 equals A, B to the negative second, right? What are we going to do to solve for A? Well, it might be, there are 2 things we could do. Okay, I think the thing's going to be more obvious to you. This is a negative exponent, so I'm going to write this as 12 equals A over B squared, because that's what, of course, B to the negative 2 tells you, right? Now it should be pretty obvious. How do we solve for A? What do we do to both sides? Well, hopefully you're really tuned into the idea that if you have denominators, you multiply them. So we multiply by B squared. And we get 12b squared equals b squared over b squared times A. So A equals 12b squared. Okay? Now substitute that into the second. Second equation is 2 equals A B to the 7th. So 2 equals 12b squared times b to the 7th, right? How do we solve this? Well, I'm going to have to come all the way up here. I've got a little bit of board space, and that's all I'm going to need. Okay? So we got what? Well, how do you simplify 12b squared times b to the 7th?
The base.
Again?
Combine the base.
Yeah. You use the laws of exponents, right? And you get b to the 9th. I mean, this means b times b. This means b times b times b times b times b times b times b, which gives you b times b times b times b times 9 times. Okay? So that gives us 2 equals 12b to the 9th. What are we going to do to that?
Get B by itself.
Yeah, we're going to get b by itself, so how are we going to accomplish that? What do we do to both sides? I'm sorry?
Would you divide by 12?
Divide by 12. So I'm not going to go through the details of writing all that out. We get 2 over 12 equals b to the 9th, right? Okay. And then 2 over 12 is 1/6, so we have b to the 9th equals 1/6. And how do we solve that for b? Going to use laws of exponents. You're going to say b to the 9th raised to the 1/9 power is 1/6 raised to the 1/9 power. Okay? Now what's b to the 9th to the 1/9?
B.
It's just b, but why is it just b?
They cancel each other out.
You multiply the exponents, right? If you raise a power to a power, you multiply the two powers. So that's, and I've done this, I did this, I think in our last class too. That's b to the 9 times 1/9 equals 1/6 to the 1/9, so that b to the first equals 1/6 to the 1/9. It's b to the first because 9 times 1/9 is 1. So you raise 1/6 to the 1/9 power. Okay? And you get probably something like 0.8. 0.8. Yeah, probably a little less than 0.8. So I'm guessing between 0.7 and 0.8. Okay? Yeah, it might be 0.8. Anyhow, punch that into your calculator. Raise 1/6 to the 1/9 power. Okay, don't do that now. This isn't a calculator exercise, but if you can't figure out how to do that, stick around for a minute after class and deprive me of my taco. That's okay, I don't need the taco. I'm going to get a hamburger today anyway.
Did you get it already?
Huh?
Did you get it already?
No, no. I can live without the taco, but if I get the chance, I'm getting one.
You want me to go get you one?
No.
You sure?
If you do, I'm going to eat it, and then it's going to mess up the whole lab. No, I don't want one now. I'll get one hot, or I'm not going to have one at all. But thank you very much for offering. Still, I wish you'd stick around and, you know, get the math down, although you're doing quite well. Okay, wonderful.